Hey guys, it's Mr. H with 1NCLEX Solved, and today I'm going to be discussing dosage calculations. What I'm going to do is I'm going to go through each one of these questions, and I'm going to show you guys how to bypass all the fluff, all the information that's usually confusing, and how to hone in on like the specific details so you can plug in all your information into the formula that's supposed to be utilized for each one of these questions. So to start off, number one, it says, a nurse is preparing 15 milligrams of morphine subcutaneously. The amount available is morphine injection 0.5 grams for every 2 mLs. How many mL should the nurse administer? Well, there's a lot of information here. First thing I want you guys to identify is exactly what is the question asking you. Well, how many mLs should the nurse administer? Whenever you guys have a question, and sometimes you guys are going to see a lot of other information within the scenario, but if it's asking you how many mLs, if it's asking you for tabs, if it's asking you for capsules or for milligrams or micrograms or any particular unit, okay, if it's asking, or even milliequivalents, which they utilize for electrolytes like potassium, if this is what the question is, how many of these, it's going to be D over H automatically. So D over H stands for drug that the doctor ordered, or the order, divided by what's on hand or what's available, and you multiply it by the volume or the quantity. And I'm going to show you guys how to get to that right here. So the first thing I want to identify is the doctor's order. A nurse is preparing 15 milligrams of morphine subcutaneously. Since the nurse is preparing it, we can infer that there's a particular order for it. So now we have our D. So it becomes 15 milligrams. And we're going to divide it by what we have on hand. So the amount available and on hand essentially are interchangeable with one another. It means the same thing. So we know it's 0.5 grams, 0.5 grams. And then per every 2 mLs, that's the volume or the quantity, and we can multiply it by 2. The downside right now is that we don't have like units. Gram is bigger than milligram, milligram is smaller than gram, so we can't divide them, we can't compute them. So because of that, you guys can select either one of the units and convert to, so they can be like units. So what I'm going to do is I'm going to stick to converting whatever the doctor's order is. So the doctor's order calls for milligrams, and I have my grams right here. So when it comes to converting units, it's actually very easy. A lot of people say it multiplied or divided by 1,000 or 100 or something like that, right? Well, what I like to do is this. Pick one. I'm going to pick the grams. I know that gram in comparison to milligram, it's bigger. So when I think of bigger, I think of right, because I'm right dominant. And it's bigger, it's right. So you're going to move that decimal 3 spaces to the right, and it becomes 500 milligrams. Then we can rewrite the equation as 15 milligrams divided by 500 milligrams, which equals 0.5 grams. And we multiply it by 2. I have my calculator with me right here. If you guys follow along, you can actually compute yourself as well. We get 15, we divide it by 500, it gives us 0.03, and then we can multiply it by 2. And then it gives us, I'll write it right here, equals 0.06 mLs. And that's essentially your answer. I know the numbers look a little bit unrealistic because I'm just making them up, but that's a good tool to utilize to find out what dosage calculation you're going to be utilizing, or what formula you're going to be utilizing. Moving on to the next one. Number 2 says, a nurse is preparing to administer 0.9% of normal, sodium chloride, 1 liter IV to infuse over 8 hours. The drip factor is 15 drops per ml. How many drops per minute should be given? Well, we go back to the basics again. You go back to what exactly is it asking you? And this is a question. How many drops per minute? Whenever you see the GTT, the drops per minute, you should know off the bat that the formula to be used is drip factor, which is total volume times drip factor divided by time in minutes. You need to memorize this particular formula. So all we have to do now is plug in. I know you see some other numbers like 0.9% that usually confuse the students, but does it say anywhere that you're supposed to plug in a percentage? No. So what you end up doing is you find the total volume. The total volume though has to be in milliliters. So where is our volume? right there, 1 liter. 1 liter right here equals 1,000 milliliters. And these are units of conversion that you guys should know by now. And if not, I'll set up another video to explain those as well. So we have our total volume, 1,000, multiplied by DF, the drip factor. And the drip factor in this equation, they gave it to us. It's 15 drops per ml. We can plug in 15. And the time is going to be 8 hours. But the time has to be in minutes because that's how the question is being asked. How many drops per minute? So you're going to have to convert the hours into minutes. And the best way to do that is whatever the hours are, you just multiply it by 60. So you get 60 times 8 hours, 48. So it becomes 480 minutes. For those of you following along, go ahead and plug it into your calculator as I'm going to do right now. So you get 1,000, you multiply it by 15, and it gives you 15,000, and then you divide that by 480, and that gives you your answer of 31.25 drops per minute. Hopefully that kind of helped out a little bit. And then for the last question, this is usually a little bit tricky because students get really confused. So let me try to attack this question so I can clear some things up for you guys. So it states, the drug reference book states that it is safe to administer 3 milligrams per kilogram for every 6 hours of a particular drug. I'm not going to put any drugs up there, just any drug. So it's saying that it's safe to give 3 milligrams per kilogram every 6 hours. What is the dosage or the safe dosage if the client weighs 68 pounds? Now notice that they're giving you pounds here. The first thing you want to do when it comes to milligrams per kilogram questions is you convert the pounds into kilograms. And we should all know that 1 kilogram equals 2.2 pounds. A lot of students get confused as to, well, how do I know if I divide or I multiply? Well, I'll give you guys a little trick that I use. Notice that 1 kilogram and 2.2 pounds, it's the same weight, but the number unit, meaning just the number, is always bigger when it comes to pounds versus kilograms. It doesn't say that this weighs more than that, no. They're both equal in mass and weight, but the number unit in pounds will always be a larger number than the kilogram. So if, let's say, you're going to try to convert these 68 pounds into kilograms, well, let's see what happens if you divide or multiply. Let's try multiplication first. If you get 68 pounds and you multiply it by 2.2, it gives you 149.6 kilograms. Now, you might have done this by mistake. This is the incorrect way of doing it, but let me show you how you can safeguard yourself from understanding that this is incorrect. And you know that division is going to be the appropriate answer. Let me show you guys. So again, 1 kilogram is equal to 2.2 pounds. This logic states that the kilogram value, when equal to pounds, will always be smaller, a smaller numeric value than the pounds. Does this answer follow that logic? Are my kilograms smaller than my pounds? You guys can see. It's not. 149.6 kilograms equals 68 pounds. That's incorrect because the pounds right here is bigger, is smaller than the kilogram. So you know that if that's the case, then we have to divide. So then we divide 68 pounds by 2.2, and we can plug that in also in our calculator. I want you guys to be doing the same thing. 68 divided by 2.2, now it gives us with an equal of 30.9 kilograms. Now this follows the logic that I was describing. We have a kilogram value of 30.9 that equals a pound value of 68 pounds. Now this follows the logic. The numerical value of kilograms is smaller than the pounds, just like it does in the original formula. So hopefully that kind of helps out with the conversion from pounds to kilograms or kilograms to pounds. So the first thing we have to do, since we figured out what our kilograms are, it tells you right there, this is the formula. You can give 3 milligrams for every kilogram. Well, if you have 1 kilogram and you can give 3 milligrams for every 1 kilogram, well, that's 3 milligrams, right? If it's 2 kilograms, you multiply it by 2 and that gives you 6, and so on and so forth. So what we're doing is multiplication. We're getting the 30.9 it's not cooperating with me. We get 30.9 and we multiply it by 3 milligrams. And that gives us 92.7 milligrams for every 6 hours. So in computing this problem, I'm going to read it again. The drug reference book states it's safe to administer 3 milligrams for every kilogram every 6 hours of a drug. What is a dosage if the client weighs 68 pounds? Well, we did the conversion. You divide by 2.2, it gives you 30.9 kilograms. That equals 68 pounds. And then you multiply the kilograms by the milligrams that it's safe to give by. And it gives us 92.7 milligrams every 6 hours. And that's how you compute these dosage calculations, guys. I hope that helped out. Leave a comment down on the comment section. Please subscribe to my channel, and I'll be providing more videos as time goes by. Thank you.